I see that we've got about 30 participants and a couple more will trickle in, but to be respectful of time, we'll just get started. So hi everyone, welcome to the second webinar in our Forestry and Conservation webinar series. I'm really excited to be talking about caribou and forestry this afternoon. For those of you that don't know me, my name is Tara Russell. I'm the program director with the Canadian Parks and Wilderness Society Northern Alberta chapter. CPAWS CPAWS is a nationwide conservation organization focused on the conservation and protection of public lands across Canada. And here in Alberta, we're fortunate to have two independent chapters, the Northern Alberta chapter and the Southern Alberta chapter. We kind of divide ourselves around Red Deer, but we come together to work on important conservation initiatives, such as better management of Alberta's forests. So I am here joining you from Edmonton on Treaty 6 territory and in Métis Region 4. These are the homelands and traditional territories of the Cree, Blackfoot, Métis, Nakota Sioux, Iroquois, Dene, Ojibwe, Saulteaux, Anishinaabe, and Inuit, and many others. But the work that we do between our two chapters is across all of what we now call Alberta, across Treaty 6, 7, and 8. And I really want to acknowledge and express my gratitude to all of the First Nations, Métis, and Inuit people whose stewardship of these lands and waters and resources continues to shape our work, both through our partnerships as well and through their leadership. So I do invite everyone that's in attendance today to just take a minute and reflect on the Indigenous lands that you're joining from and your relationships to them yourself. So with that said, we're incredibly fortunate today to be joined by Dr. Robert Serrouya, as well as Melanie Dickey, to provide us with approximately a 45-minute presentation on, like I said, one of my favorite topics, caribou and caribou conservation in Alberta's forests. It'll be about 45 minutes of presentation, and we'll have some time for some questions at the end, hopefully about 10 to 15 minutes of questions. And those can all be asked in the Q&A box. So that should be found at the bottom of your Zoom screen. Please place all of your questions in there. And you can also thumbs up or I think you can only thumbs up questions. If someone's already asked yours, you can pop it to the top. And we'll have Josh Killeen from our Southern Alberta chapter helping us sort through some of those questions as well. And I'll pass it over to you, Dr. Serrouya.
Thanks, Tara. It's a pleasure to be here. And sometimes I feel like I have imposter syndrome when talking about Alberta, because there's others that are definitely more in the trenches than I am, but like Melanie, who's on this call as well. But yeah, it's still really fun to work in both provinces, because there's a lot of insight we can gain ecologically by looking across ecosystems and management policies. So there are lots of natural little mental experiments we can do when thinking about Alberta and BC. A lot of things are similar in terms of what are affecting caribou, the factors affecting caribou, but policies can differ a lot and ecosystems can differ a lot. So, you know, we're not physicists. There's not a consistent universal truth when it comes to how ecosystems respond to natural and anthropogenic disturbance. So today, as you mentioned, Tara, I was going to talk about caribou and forestry and habitat and what really matters, some of the numbers, or should I say metrics, that really matter. And there's a lot of obfuscation in terms of what are the clear numbers, and I'll try and sort of get through that fog. And and just to say, this is also a talk that I have updated since giving most of this in Alaska at the North American Caribou Workshop, not this spring, but the spring before, in May 23. So yes, these are different designatable units of caribou, and I guess one key point is that in the southern mountain group of caribou here in BC and Alberta, which is about here, southern mountain group, there have been 12 extirpations. 12 populations have gone extinct since the year 2000, and the transboundary herd with Idaho and Montana was extirpated in 2018. And what we often think about is, well, okay, how do we prevent those extirpations in the short term versus the long term, proximate versus ultimate? And in the short term, society tends to remove predators, and that's been going on in BC and Alberta for 10 to 20 years, depending on which populations. In Little Smoky, a little longer, since 2005, but in BC, it really ramped up in 2015. And we often hear these quotes, well, we are removing predators until the habitat recovers, because it's just an interim strategy. It's an emergency measure that buys us time. I've written that in various documents. And yeah, we tend to say this a lot. But the question is any of this true, or are we just kidding ourselves when we say it's an interim measure? Because if we keep removing the habitat, it's not an interim measure. It becomes an indefinite measure. And some of my colleagues did a great job in terms of calling out this logic. And they agree that wolf reductions work, but what are the ethical implications if habitat keeps getting removed? And is it problematic when people confuse or conflate the ethics of predator removal with the efficacy of predator removal? So I've been getting more interested in the ethics lately, especially as it revolves around habitat. And my colleague Blair Steinwand at UBC Vancouver has been piloting these questions, a whole bunch of questions, but I'll show you the two extremes in her undergraduate classes. And the answers are similar each September. Every September, when she pilots them with very little context, just to get their snapshot answer, she asks, would you kill wolves to save BC's caribou? And most folks say no. Nope. Why is that cool? Nope. But what about if you also protect their habitat? And we ask questions on varying degrees of habitat protection, complete versus partial. But in a binary sense, the answers flip. So maybe folks recognize that if there's a certain amount of habitat protection that can act as an umbrella for caribou, then they're more tolerant of wolf removals. But again, the question is always what we get asked by peer reviewers and the public is, for how long? And I'll try and break that down a bit. I'll unpack that how long question by talking about different mechanisms of habitat alteration. When you log, and I think everyone on this call, on this webinar knows the story, when you log, you get more early cereal vegetation that leads to more primary prey, moose and deer, which leads to more wolves and fewer caribou. Another mechanism, though, is that when you log, you remove caribou food. And in some herds in BC and even in Alberta, this kind of arboreal lichen that grows on mature trees, this is Bryoria and this is Alectoria, two different genera of lichen. When you remove trees, you remove their food source. And this also brings in the concept of core habitat. Lichen removal happens in core caribou habitat, but this dynamic that I mentioned also happens beyond core caribou habitat in the area surrounding where caribou live. That's why it's such a problem of scale. Like, caribou do require large areas that are undisturbed if they're to be self-sustaining. So when you kick it out big scale, activities well outside their core, like this, can occur outside the core habitat. Can folks see my cursor when I'm panning around? Yeah, okay, cool. Maybe it's kind of skipping. I'll just get a little mouse pad here. There we go. That's a bit smoother. Yeah. So disturbance that occurs outside the core can also affect caribou, which makes it tricky. It means that the scales are huge. Another mechanism that Melanie works a lot on, Melanie Dickey, is how linear features affect the movement speed and incursion rates of wolves into caribou habitat. So that's less of a numbers game. It's less about the numbers of moose, deer, and numbers of wolves, and it's more about how efficient they travel and exploit their resources across the land. So those are the primary mechanisms. Okay. At the beginning, I talked about metrics of interest. What should we be tracking as members of the public, as managers, as environmental groups, as forestry companies? What really matters? And something we do tend to track is the state. So what is the percent disturbance? So percent disturbance by range, and state is different than rate. Rate implies a change over time, and state is just a current snapshot. So Alberta does a good job of documenting the state of disturbance, and they produce documents like this, which has graphs like this. So which of its ranges in the boreal part of Alberta achieve 35% undisturbed or a 65% disturbance threshold. And that includes buffers. So yeah, the goal is towards having 65% undisturbed. So a max of 35% disturbance in each of these boreal ranges. And we can see that when you consider forestry and fire, and that forestry has a buffer around each disturbance, forestry and oil and gas extraction, none of the ranges reach this 65 undisturbed target. And I don't think that is a surprise for most folks on the call. The closest ones are more sort of northern ranges, and then the Little Smoky and Slave Lake are the most disturbed ranges. Another metric is how is the amount of tree removal changing over time? So a gross rate, not a net rate, but a gross rate. And we can see for populations like Little Smoky or Chinchaga, the amount removed over time has been increasing. And again, that's not a surprise. So this is the cumulative amount of forest removed by decade. So that's the amount harvested, and that's the amount burned. And yeah, these are not meaningless amounts. They do matter. But what I want to try and float with everyone here and try and impart in terms of what probably matters the most. Sure, the state matters. Sure, the gross rate of loss matters, but trees grow back. And it's absolutely true that trees grow back, and there are different mechanisms at play when trees grow back. Moose food and deer food disappears after a certain amount of time, or it starts to truncate as the trees grow back, as the canopy grows back. And over an even longer time frame, lichen on the ground or in the tree canopies also come back. So I really want us to start thinking about the net rate of change, because that's probably a more honest and a more accurate approach to the definitions of what forest change is. So that would be, the net rate would be what's disturbed minus what's recovered, and that gives you the net. But the rub is, what is recovered? What is the definition of habitat recovery? And that's going to vary by ecosystem and by mechanism. So the mechanism of growing moose and deer food will differ very much from the mechanism of growing lichens. So in the federal definition, it's visible on Landsat, but other people wonder about 40 years post-fire. Does it come off the books in terms of disturbance? Or should we focus on what the animals and plants are telling us? So I'll try and get into that a little bit now. About 3 years ago, we put out a paper with Mariana Nagy-Rees as the lead author where we tried to float this concept of net change. So this would represent a 10% gain for this particular herd number 43 or whatever it is, over a 12-year period. So that's the net change over a 12-year period from 2000 to 2012 when these data existed. And the first thing to see is that most herds in Western Canada have a net loss. Again, not surprising. All the herds in Alberta have a net loss. So these are boreal herds, and these are mountainous herds that are part of the SMC. All the pink variations are southern mountain caribou, and they're transboundary herds between BC and Alberta. A few herds in BC have had positive gain, net gain, under the definition of 5 meters tall means that moose and deer food have come offline. And I believe that those are the herds, in my mind, where conservation and increased protection began in the mid-90s under something called the Ministers' Advisory Committee. And forestry was constrained. 40% of the old growth that's harvestable, 40% of the old growth had to be retained in these units from the Heart Ranges here down to the US border. And some of those have moved the needle where gain is exceeding loss, that net improvement. The problems with this paper that we put out, though, is that the data to track this stopped in 2012. It was super coarse because it was relying on Landsat, not local forestry maps that the government tracks, and it's not really suitable for detailed tracking. So some of the solutions we're putting forth and that I address here is that we should be tracking each individual cut block, because at least the government of BC, I'm not as certain about Alberta, but the government of BC has a very up-to-date layer on every single cut block that's occurred over the last 40 to 50 years. So we can track the time since disturbance, and we can track the seral change over time. And we also think, okay, an improvement over that Landsat that I just presented is to let the plants and animals inform our decisions. So let's talk about plants for a minute. Recall that I had this topic about more leafy young plants, and we can coarsely track those using Landsat, using delta EVI. So that's the enhanced vegetation index, that we simply track the amount of deciduous vegetation over time just by subtracting a winter pixel, a winter metric where there's no more leaves, from the summer where there are leaves. And the difference between the two, and the conifers don't change, of course, between winter and summer, except for larch. And the difference between the two gives us the net, the delta, or the net difference in vegetation. And our Quebec colleagues have done a great job of measuring plants on the ground and correlating it to this delta EVI, this vegetation index. So the more EVI value, the more moose food exists on the ground. And then in a separate paper in ecology, Melanie Dickey showed that the more delta EVI, the more moose food estimated from Landsat, the higher the moose density. So all these steps in the chain, or these linkages, can show that, hey, if we have more leafy greens, we have more moose, and that's not necessarily a positive thing for caribou. Now, I'm flipping back and forth between BC and Alberta, and again, like I said, it helps us gain insight. But we had this pilot study in central western BC for these 4 caribou ranges, and there's a lot of different ecosystems here. You have plateaus here versus big mountains, and caribou live across these different places. And we get a different response to disturbance in these different ecosystems, from coastal western hemlock to montane spruce to subboreal pine spruce, subboreal spruce, interior Douglas fir, and the Engelmann spruce subalpine fir. The 0 line means when the area was logged, when that each one of these dots represents a cut block that we've tracked through time. And the take home here is that some areas produce a boon of this delta EVI of this moose food, and some areas do not. Like the montane spruce, there isn't a big change in leafy greens because it's kind of a nutrient poor soil type. But in some areas, you get a big bump in delta EVI, which again, as I've shown in the previous slides, produces more moose food and even more moose. So all those links in the chain. And that's where what I mean by this blanket prescription of 40 years or visible on Landsat that the federal policies had to do 10 years ago when these tools didn't exist. They had to make a decision. So that's totally fair. But since then, we've been able to refine different recovery pathways and the intensity of moose food that's produced post-disturbance. And we can do this for both fires and cut blocks. And in some places, they mirror each other pretty tightly, and in some places, they don't. Now, that's the plants. What about the animals? Some colleagues, Matt Muma and Mike Gillingham and others, looked at how moose select time since disturbance. So cut block age on the x-axis, so that's 0 years old, and this is the intensity of use by moose on the y-axis, and the black dots are like a selection ratio. So in early winter, moose are selecting cut blocks since disturbed at the peak of about 14 years old, and then by about 20 years old, that selection wanes. In fact, they kind of become avoided. In late winter, it's a bit later on in time, so it varies by season. But in some seasons, it's actually a relatively quick time till recovery, where the forests no longer produce moose food. My student Mateen did this in the Revelstoke area. Same kind of thing. Moose started selecting cut blocks about 12 years after they were disturbed, and then started avoiding cut blocks about 36 years after they were disturbed. So we're finding some consistencies in different ecosystems. But again, the boreal is going to differ from the montane spruce, from the cedar hemlock, and I think it's important to measure that in different ecosystems. So what I would conclude here is that there remains uncertainty in terms of what is recovered from a definition of caribou, but in the meantime, we should be giving different areas different priorities to define recovery and different managers. And maybe I'll just skip over some of this and switch to another tracker. So I want to introduce this topic of a near real-time, think of it as annual, online habitat tracker that the public can use. And oh, there it worked. Okay, good. So this is a total beta introduction version, and we've done all this for Alberta and BC now for all 70 ranges in the 2 provinces, but we haven't mapped it for Alberta yet. So let's say okay, this range would be Barkerville, which is up here somewhere. And these lines for forestry represent the net value. It is disturbed minus recovered. So for Barkerville, the early serial net value is still increasing, the percent of range disturbed. So that's not necessarily positive for caribou, because the harvest level is still increasing. But for other herds where that protection has been in place since the 90s, we've started to see that line leveling off. So let me turn off the total disturbance and just focus on forestry. So this would be Columbia South, which is this herd here. The early serial has flattened and may even be declining a bit, probably because of that GAR, the government action regulation, to sort of reduce and limit the amount of forestry that's going on in those ranges. So the hope is within 6 months, this will be a publicly facing tool that any decision maker, member of the public, member of industry, whomever can transparently click on a range and see what the status is. This is Clinziza, where the big park was formed. The whole area has been stopped for harvest, almost the entire area that the Saulteaux and West Moberly First Nations have instilled. And the maternity pen is there that's almost quadrupled the number of caribou since 2015. The early cereal is still increasing. The blue line's still increasing, but that's because we had a big set of fires a few years back. So it'll take a while before this blue line and this total black line turns the corner and starts declining. But what's interesting is that users, depending on what they learn about the ecosystem, can define what recovery is. If it's moose food, maybe it's only 20 years, like what was shown by Matt Muma. So then the blue line is a bit more promising than when I just showed. But if it's lichen, oh, let's turn it up to 60 years for recovery. Oh, then the blue line is still cranking up. So users can define what the harvest recovery is with guidance. We will provide guidance for that ecosystem. Okay, let me flip back to the presentation now. So what I just showed, we've summarized in static graphs. So if recovery is 30 years, some herds are doing better. The blue line is declining, like the Central Rockies herd. The blue line of early cereal is declining, so that's good. But if it's 40 years or 60 years for recovery of that forest type, no, it's still getting as a higher percent of the disturbed range. So I can go through this for different groups. Different groups of southern mountain caribou. This is the central group. This group did not have the GAR, that protection put in place in the mid-90s. So all the blue lines are still increasing. It's not like the southern group where in the 90s that protection was put in place, and a lot of them are improving. The blue line is declining. Okay, so I showed the real-time habitat tracker that Peter Solomos is coding for us. I think I'll just keep going. One message I'd like to point out here is that for some populations, we have now these catastrophic fires. So the red line represents fire. So the Ichthyosaurus had a huge fire in 2020 or so. And we don't yet have a mechanism with forestry to say, okay, we had a big fire. Should we have a coordinated concomitant offset of harvest? Like if a range burns, yes, we do have timber supply reviews every 5 years, but if a range burns and creates more early cereal on the landscape, that's the black line, the total early cereal, well, maybe there should be a real-time offset in logging to offset that bump in fire. And that's what we're hoping this tool can clarify. We rarely talk about how annual allowable harvest should offset loss to fire. Maybe we should have an early cereal target in each range that we adhere to regardless of whether the disturbance is forestry or fire. So back to my original question from the first slide, are predator reductions really an interim strategy? So let's break it down. This shows the number of herds in BC and Alberta, where gain, forestry gain, the habitat gain exceeds loss. So in the southern group, so that would be here in the dark purple, dark pink purple, these guys, 18 of the herds, or 78% of the herds have gain exceeding loss. So the picture is improving in those southern groups. And 3 of the 4 herds where wolf control is applied also show a gain in habitat metric. So maybe it is an interim strategy in those herds. But the central group in Alberta, so those would be these ones, Alapesh and Narroway, there's 4 of them where 3 of them where wolf control is being applied. None of them have gain exceeding loss. So loss exceeds gain in all 3 of them. If you look at Boreal Alberta, where we're doing wolf removals, and I say we, it's the royal we, it's society. 2/3 of the herds have gain exceeding loss where wolf control is occurring. Okay, that's positive. But if you include fire as well as forest harvest, none of the herds have gain exceeding loss because fire is the dominant disturbance in this part of the world. And where wolf control is applied, none of the herds have gain exceeding loss. So that becomes more difficult to argue that it really is an interim measure or an emergency measure. Okay, so I've introduced the concept of state, rate. These are the net rates, these curves. Now, what we should be debating as policymakers in society, yes, indeed, targets are laudable, but I would argue that we should at least try and have the needle move where the net rate is positive. Even if it's just 1% a year, that's better than the alternative. And what time period should that rate be specified for? But what we should be doing is annually reporting on that net rate. And that's why we're developing that app, that online app that I showed you. Now, here, maybe I'll skip over that one. Something that's hot off the presses as of Friday is a debate in the literature about what's driving the expansion of white-tailed deer in Alberta. As we know, white-tailed deer is not good for caribou because of the apparent competition. So white-tailed deer expand, more predators become established, and there are fewer caribou because of higher predation rates as a result. So as part of Melanie's PhD, we've taken advantage of this contrast along the Saskatchewan-Alberta border. Alberta has a lot of disturbance, all the dark shading, and Saskatchewan has less. It's about at least a quarter the amount. And in these areas, we've put out these squares that each have 25 cameras to measure primarily white-tailed deer abundance. And we are asking what I think is one of the most important applied questions in ecology globally. What is driving change? Is it habitat alteration or is it climate change? Or is it a combination of both? Of course, we know it's not either or, that's a no-brainer. But we want to try and assign the relative importance of each because if it's, let's say it's mostly habitat alteration, well then restoring and protecting will have your bigger effect on deer and hence caribou. But if it's mostly climate that's affecting whitetail abundance and distribution, well, then that forces you into a position where you got to make more difficult decisions. You got to prioritize where you should restore and protect because you could restore and protect all you want. But if whitetails are going to be there anyway because of climate change, well, then you might be wasting resources. And so this analysis helps to contextualize that dichotomy, let's say. And it's a bit of a false dichotomy anyway, but it helps to clarify where to allocate resources. And in Melanie's paper, she found that habitat alteration mattered. The more habitat alteration, the higher the deer density was based on those cameras. But the climate effects, so more severe winters, resulted in fewer deer. And the climate effect had about a 2-to-1 ratio on the magnitude. Magnitude simply means slope, the magnitude of the relationship. And the climate effect was statistically significant. The habitat effect was not statistically significant, but I put very little emphasis on statistical significance. I am much more into the question of what is the magnitude of the effect and how precisely did you estimate that magnitude? That I'm putting in a little cheeky. So climate effects were stronger. Does that mean industry's off the hook? Of course not. It means that you have to strategize on where you may want to affect restoration and protection. And certainly in colder areas, there were, in warmer areas, there were deer regardless of the habitat effect. So maybe we should be focusing protection and restoration on the colder areas. So our good friends and colleagues here, I guess their names are not on here. I guess it got cut off. They put out a paper that came out on Friday. The influence of white-tailed deer on density of invading white-tailed deer should not be, the influence of habitat alteration should not be discounted. And we put out a counter piece. Both of them came out on Friday, and I'll just quickly cover what our colleagues say. And this is, I consider it a really fun discussion because they're not wrong in terms of what they're saying, and we're not wrong either, but there is something I would quibble with. And our bars are in red, and their data is in blue, and they use the same data as we did. They just used a different transformation, a different way of normalizing or centering the data. So with their approach, they found that habitat alteration was statistically significant and positive, so above the zero line, so more habitat alteration, more deer. We found that climate was the dominant factor, but also an interaction of habitat and climate. So we didn't find that they were isolated, but they worked together. So it's a little bit of statistical jargon. Yeah, and the key difference being that with their approach of Z standardization, they found a positive and statistically significant of habitat alteration that was, yeah, they say was an equal magnitude to climate. We found it 2 to 1. They found it 1 to 1. You know, is it that important? I played this little game where I converted the deer biomass, the deer numbers, to wolf numbers, which is well established in the literature. And I found that regardless of whether you use their statistics or our statistics, you are still above that magic number of 3 or 6 wolves per 1,000 kilometers squared. So you're still at 7, 8, 9, 10, 11 wolves per 1,000 kilometers squared, whether you use their predicted deer values or ours. So you, regardless of what you say, in the southern area anyway, you're still in this game of wolf reductions. That's the sad truth. So we used their method of standardization and ours and compared the two and found that they were perfectly correlated, whether it's for delta EVI, so habitat productivity, that moose food, habitat alteration, or climate. One thing I will quibble with in their paper is that they said, using their approach, the Z standardization, we found a different conclusion of equal magnitude of, but opposing inference of opposing effect of climate. So colder, that's why this is negative, more cold, less deer, and habitat alteration, more habitat alteration, more deer. They're saying that these two values are equal, but that ignores that there's actually an interaction. So you can't say they're equal because they differ under different levels of climate or habitat. They interact. It's not this static thing. And Mel, maybe I'll get you to jump in here and explain. I think this one is the one that matters.
Yeah, for sure. So if you look at panels C and F, which show the same thing, just with the different transformations. So let's focus on C. The purple line is harsh or is mild winters. And what we can see is that when winters are mild, it doesn't matter how much habitat alteration there is, there are deer present. As we get more habitat alteration, there are more deer. But even if we have zero habitat alteration, we have deer present on that landscape at an abundance that is too high to support self-sustaining caribou, as Rob just mentioned. Whereas if we have harsher winters, so the blue and then into the yellow with the harshest winters, we don't have any deer present unless there is lots of habitat alteration. So that's that interaction that we have to be really careful about what landscape we're talking about and what climate parameters we're talking about when we're interpreting the other one.
So my point is, yeah, exactly. You have to plot the interaction of all the things that are going on, rather than just saying, oh, climate and habitat are of equal magnitude. That ignores the fact that there's an interaction. And in fact, you can't say that just because these numbers are the same, 0.9 and 0.9, that they are the same. They depend on the level of each other. Anyway, it's a bit statistical, but yeah, the take home of ours is that regardless of whether you use the min-max standardization approach or the Z standardization approach, you get the same inference. They're correlated at 1-to-1. So yeah, that you'll see this all over Twitter right now. There's a friendly debate going on between among our colleagues, and we're supposed to have a Zoom call together. So I'm looking forward to that. And yeah, with that, there's 15 minutes left for questions. I hope that yeah, I hope this was informative for you folks. Should I stop sharing, Tara, or I'd probably leave these on in case people ask?
You're welcome to leave your slides up in case you want to flip back and forth to asking them. And we're welcoming folks to put questions into the Q&A box now. I guess first, thank you so much to both of you for providing all of this information. It was really excellent, informative, and I think we all love being brought into like a little bit of academic drama. It's always fun to feel like you've got the insider track to that. So,
It's true.
we've got 3 questions so far, and again, folks in attendance, please put your questions in the Q&A box. But I'll go with the first one that came in a while ago, from Sarah Nason. Do we know how much about what the forestry companies are doing in response to the harvest limitations in those areas in BC? And I think that's the limitations in response to, Sarah, the GAR.
Yeah, the GAR, exactly. Yeah, that's
Are
a
they
very
gonna harvest? Yeah, sorry, I'm gonna finish reading the question just in case the recording. I'm wondering if they're still trying to meet a certain annual allowable cut, so these regulations may be pushing them to go harvest in other areas, and maybe this contributes to the higher harvest levels seen in northern BC.
Yes, so that's, like I was saying, that's a really good question, because there are definitely cases and evidence where the harvest is being shunted elsewhere. But bigger picture, BC is facing a problem that I'm just surprised is not addressed more in the forestry academic community, and that there's a timber supply fall down, particularly with the pine beetle that was large, you know, the pine beetle from 2000, early 2000s, mid 2000s, the huge pine beetle swath centered on Vanderhoof. Most of that was outside of caribou habitat, but the analogy I heard was that we logged 60 years of wood in 20 years to salvage log the dead pine trees in that montane spruce ecosystem. So wherever you go, regardless of unit, whether it's caribou or non-caribou, we have a big timber supply fall down in BC, and often caribou gets pointed to, the caribou constraints or the caribou protection measures get, oh, we have less wood to harvest because of caribou. No, I don't think so, although I've yet to see a really good analysis on this, but it's more likely because of over harvest for salvage logging and just regular intensive harvest that occurred in the 80s, even in the old growth ecosystems around Revelstoke where I live. We're dealing with a shortfall. So every curve I see shows a big fall down. So the question is, do we want to hit that cliff in 15 years where the available timber supply then plummets and then only comes back in 60 years at half the current level? Or should we start weaning ourselves now and not dig into our capital, our old growth capital? So I hope that helps, Sarah.
Thanks for that, Rob. I guess a small interjection from myself here. Do you see the same trends in the timber supply happening here in Alberta?
Some units, yes, for sure. Others, there's a lot of pine coming back online, actually, that will be available for harvest. I can't remember where. I think it's in North Central. Yeah, I remember seeing curves where there's actually abundant forests coming back online to harvest in short order. I think Tom Habib may be on this call. He could answer that, or Melanie.
Thanks. I can follow up with them separately if that's all right. We'll get to our webinar attendee questions. The next question is, in your questions, do you include any level of certainty of saving caribou? Obviously, with climate change affecting fire regimes and white-tailed deer, is it anything but certain that caribou will be around long-term, even with protection of old growth?
Yeah, we try and do our best, of course. So we have a big paper that came out in March or in April that showed the different effectiveness of wolf management, maternal penning, supplementary feeding, and we have uncertainty on their effectiveness, really well presented and quantified with big confidence intervals or well quantified confidence intervals. So we know what to do in the short term as society with uncertainty, but it's fairly fairly limited level of uncertainty, I would say, on some of the levers like penning and wolf removals. Feeding is a little more uncertain, but when you throw in climate change in terms of the long term, yeah, we and our other colleagues as well are modeling how changes in forests and particularly changes in white-tailed deer will affect the intensity of short-term management that will be needed, like predator removals. If climate change is going to affect the abundance of white-tailed deer upwards by 40%, with X% uncertainty, then you can bet you'll have to do more in the short term to keep caribou on the land.
Thank you. It's possibly not the most uplifting answer we were looking for. This next question is from Jill Roberts. She says, thank you so much for this webinar. For Alberta and elsewhere, with caribou gains exceeding losses, what purpose, in your opinion, do the wolf kills serve? Is it a way of avoiding the real problem of continued habitat destruction by industry?
Where gains exceed losses and wolf control is occurring, if you don't do the wolf control, the herd is very likely to go extinct. And we have strong, I could probably bring up a graph on that topic if I can work quickly on my feet. But yeah, if even where gain is exceeding loss, you still have the moose and deer out there that are buttressing or propping up the wolf population. So if you don't do that short-term work, the herds will decline. And then once the herd goes extinct, you will have a strong impetus to put the forestry protection tenures back into the rotation. So I hope that answers your question.
I see a quick correction here where she says she meant losses exceeding gains.
Oh, I see. Okay, that makes more sense. Yeah. Yeah, then it's just a subsidy. Yep, it's a subsidy, and that's why it's a subsidy by basically, yeah, as some colleagues have said, by it can allow industry to continue by the taxpayer by keeping caribou hanging on. So yeah, there's no way to argue out of that one, and that's why we're trying to show these transparent curves and see if that can link to policy to move the needle the other way. Thanks,
Yeah.
Jill. Good question.
We've got a question from the chat here from Lucy. You mentioned the use of Landsat by government only. What satellite data do you use or would you like to use?
All the tools are helpful. Landsat, when it comes to tracking early cereal, like those leafy green plants remotely, we don't have other great tools on a massive scale, but LiDAR is now going to be existing all over Alberta. Melanie's leading all of that. So LiDAR is this laser beams thrown from an aircraft, an airplane, and you can get really precise rates of veg height and veg type if there's cameras attached to the plane. And you can figure out the rate of regrowth for things like seismic line. LiDAR is really key for seismic lines. Seismic lines, rampant in Alberta, not well tracked by any Landsat type product or even forest cover. So that's where LiDAR becomes really, really critical. Yeah. And let me see the rest of that question in the chat here. Yeah, and then in both provinces, but particularly BC, the cut block data is really well tracked. So we can snip those and we have them, and we can, even 40 years ago, we know the year of disturbance, and then we can track using satellite what's changed through time. And that LiDAR is less critically needed for that. You can track that using satellite.
Thank you.
Tina's question, I don't know if I can address Tina's question about hydrology. Don't think I can. Sorry.
And then,
okay, so Tom provides an answer to that, probably what I asked help for earlier. Oh, maybe not.
do you want me to read Tom's question out? And then I
Go
believe
for it. Yeah.
a question from Josh, if we've still got some time. So Tom asks, historically, before the era of fire suppression, there likely was much more young forest than we see today. How do you square the early cereal forestry explanation of caribou decline with the historical amount of young forest? I.e., how could caribou have persisted under historical conditions with much more young forest? Alternatively, do linear features and climate change explain caribou population trends better than the amount of early cereal forest?
Thanks for the question, Tom. I would say that statement is true outside of the wet belt mountain caribou range, like where I live. For sure, the young forest now greatly exceeds historic times, and the dendrochronology studies and just the standing timber tells us that there's two age classes here. So that statement doesn't apply to a good part of mountain caribou range, but it does apply to Alberta. I agree with you. How would caribou have persisted? The only explanation I have is through metapopulation function, and that means populations of caribou in different groups, different blobs. You would have a natural fire in the year 1702. A huge area would burn, and then moose would proliferate, of course, depending whether it's uplands or lowlands. Moose would proliferate, wolves would become more abundant, and in that area, caribou would be extirpated. But they would exist somewhere else with less disturbance. And then that area would burn, and the previous area would be growing up with less moose. Moose would be waning, and caribou would slowly recolonize. So that's what I mean by metapopulations. Populations would be blinking in and out. Now, of course, we live in a different world now. We live in a world of climate change where deer are expanding regardless. And we have linear features, where I think you said something about that in your question. So we have populations of caribou declining where there is no forestry, but there are abundant linear features. So that may tip the scales when you're just on the edge of existence. The linear features in terms of the wolf foraging movement efficiency. Even if you don't get more wolves, you're getting them using the landscape more effectively, increasing the effective density of caribou and other prey. So taken in totality, those conditions don't work anymore, and we don't have that metapopulation function anymore.
Yeah, thank you for that answer. I did notice that Melanie had also suggested that she wanted to provide some answers to that. Melanie, did you also have a comment?
Sure, yeah, sorry, I tried to type it out and it didn't work. I was just going to add that those delta EVI curves that Rob was showing earlier, in unproductive areas like the boreal, for example, we don't see as much vegetation flush in burns as we do in cut blocks, largely because those burns are kind of agnostic to the habitat type that they're burning up. And so big wetlands don't have that same regeneration of moose food as cut blocks do. So that is an added layer to what Rob was saying, where historical fire regimes with younger forests might not have been as productive still as the younger forests that we see with cut blocks.
Thanks for that, Melanie. We just have one more question if everyone has time to stay on for that. And I'll just call this the last question here, if that's all right. There's a couple of questions related to wildfires. Do you see any issues with trying to hold forests in an unnaturally old state, greater than 65% on eastern slopes? And is there any value in using forestry to try and mitigate wildfire?
Thanks, anonymous attendee. I get this question about once a week now. I think it's been ramping up for probably 18 months. The guys that I mountain bike with are all, half of them are foresters, and we talk about this at the beer sessions after. Again, I'm going to strongly say that it depends where. Like under that hypothesis, where I live, we should have like no fires because, again, there's so much early cereal. If forestry was mitigating wildfire risk, we shouldn't have many because we're so far to the left on the age class distribution. Like we've got way more early cereal than the NRV, than the natural range of variation. But on the east slopes, no, you're raising a really good point. In these fire-driven ecosystems, if we're building up fuel loads, yeah, we're going to be creating a mess. So I think, and I'm not trying to deflect this question in any way. Oh, we need more study, but I think we need to work on this very carefully to see, okay, maybe in some areas we could reduce fuel loading using mechanical removal, using forestry, without growing the early cereal plants. And that can happen. In pine flats, that can happen. Or in nutrient poor sites where we're not going to get, all this cornice and yeah, moose food coming up, Acer glabrum, Douglas maple. We can do that. But we can't use it as an excuse just to keep harvesting in areas where the disturbance threshold is way beyond what caribou can sustain. And Little Smoky is an outlier there where there's a lot of disturbance, and that herd is not doing well, requires intensive wolf management just to keep the population at stable. So I would say that it really depends where. Again, Little Smoky has disturbance rates that are beyond what they could be self-sustaining. And you have to also worry about, what's the analogy, like biting your nose to spite your face. Like, you could say, oh, this potential risk of wildfire will cut, but that'll provide an immediate flush of moose food right away and within years. Is that risk worth the risk of having, more moose food on the landscape anyway, even though it might burn one day? So those two things have to be traded off very carefully. So yeah, you don't want to bite your nose to spite your face in that regard.
Thank you very much for that answer, and a huge amount of gratitude to everyone for thoughtfully engaging in questions and discussion on this really important topic. Robert and Melanie, I'm so grateful to your time today and for providing this presentation. Really appreciate you lending your expertise and sharing it. And with that, I think we'll close the webinar. It will be posted to the YouTube channel, and we'll be sending out a note to all attendees there were some that weren't able to make it today. So everyone will still be able to attend the talk.